we use the knowledge learned in transformations to compare the graph of y equals log base cx to the graph of y equals a log base c of bx minus h plus k. There still has to be a 1 in front of the x. That has not changed. If on the diploma you don't do that, that's on you. I feel like I've really drilled that home. Like, I feel like I've sold it. I feel like you're not buying it, but I for sure have sold it. Like, you need to have a 1 in front of your x. Okay? Now, the catch with log graphs is if you type in the log base 10x graph, type it in. So just like with exponentials, we can only compare graphs at the same base. Same thing with logs. We can only compare graphs at the same base. The catch when you type in a log, everyone paying attention and listening to me, because you will screw this up on the test. It's not even like you might. You will. You trust your calculator so much that you don't trust your own brains. Okay? It's a scary thing. The calculator looks like the graph stops. So when it draws the graph, it draws it and it looks like it stops somewhere in here. What happens is it gets so pixelated that this is actually the vertical asymptote, which is at what? If you can't remember, go on that line and be like, what is 0 on that line? Anything 0 on this line is an x, right? So it's x equals 0. What's happening is it gets so pixelated that it can't carry on, but what it's actually doing is it's carrying on and going all the way to the bottom. Okay? So don't fall to your calculator doing that, because if you do like second graph or table, you'll see that it actually does keep going. You know what I mean? If I put in like y equals -10, where it looks like it's non-existent, and I find out where they intersect, they do. They intersect, because the graph is actually there. Some reason on your calculators, it stops it. It makes it look like it stops. I think it gets too close to that y-axis that you can't keep going. For x equals or y? Yeah, it's erroring in the table, but it's not actually like erroring in the actual graph. And I don't know why. I think it's just getting so specifically close to that y-axis that it fits. But the graph keeps going. What's the only thing that can move that asymptote?
Horizontal translation.
Horizontal translation. So actually, the vertical asymptote on a log graph is x equals the horizontal translation. So log graphs and exponential graphs are actually inverses of each other. What's an inverse? The definition of an inverse. Swap the inverse. Swap the x's and y's. So we swap the x and y and then we solve for y, correct? So if I took a basic function like this, if I took y equals 3 to the x and I wanted the inverse of it, what would I do? X equals 3 to the y, and that would be the inverse. But often that's not the equation that's shown, right? Often they want it in y equals. How would I get that into y equals? Convert it to a log. So I would get log base 3 of x equals y. So logs and exponential graphs are actually inverses of each other. If you swap the x's and y's and solve for y, you'd have to convert it to a log for exponential to log, and you'd have to convert it to exponential for log to exponential. The key thing here is the vertical asymptote is the horizontal translation, and then my domain, remember the domain of an exponential was XER? What's the range of a log? Range of a log. YER. Why are you guys saying X's? You're scaring me. Range is never X.
It's like Monday.
But it's Tuesday. It does. Okay, so exponential graphs are XER, which means if the inverse is a log, log would be YER because the X and Y switch, correct? And then the range of an exponential is greater than the asymptote or less than the asymptote. So our domain of a log is greater or less than the asymptote. Now what could cause it to be less? So normally here it would have to be here. So what would have to happen? Horizontal flip. There's no such thing as that. I've never said horizontal flip in my life. Reflection in the y-axis.
Same thing, bro.
No, bro. It isn't. You say horizontal flip, they ain't getting any marks. Bro. Okay. X such that. Now, is it greater than or equal to or greater than? Greater than because the asymptote is on 0, XER. I get bruh way too often. That's what happens in my life. Bruh. All right. I have used transformations to sketch the graph of the function y. What is the very first thing I should do every single time I'm given an equation? Doesn't matter what unit. 1 in front of the x. You're all like, 1 in front of the x, 1 in front of the x. And the test comes, nope, it's 1 in front of the x. Even when I say, put a 1 in front of the x. All right. So, we take a 2 out. We're left with x minus 1 minus 1. So, where does my vertical asymptote come from? The horizontal translation, because I have an x equals line now. It's a log. So what's the only thing that can move that x equals line? Horizontal translation. So what is the horizontal translation on this one? 1 right. But it will be wrong if you don't take the 2 out, because you're going to tell me 2 right. It's going to be wrong, and it's going to be there, and I'm going to be sad, and I'm going to cry. I'm going to be emotional. Okay, so we write vertical asymptote because we want them to know that we have a clue what we actually just found. And instead of it being x equals 0, it's now x equals 1 because we moved it 1 to the right. We agree?
Yes.
What's the range of a log?
YER.
YER. Keeps going on for life because the range or the domain of an exponential is XER and they're inverses of each other. What's the domain?
X is greater than 1.
Why is it greater?
It is.
From the equation, not typing it into your calculator. The asymptote is 1, that's true, but how do we know it's greater and not less? It's not.
I'm saying
There's no reflection. There's no what reflection? There's no such thing as a horizontal. I've never said a horizontal reflection in my life. What type of reflection is it? There's no reflection in the y-axis. Why are we starting to say horizontal flip and reflection? Oh, good golly, Miss Molly. Okay.
This is what she should say to me. What's happening?
I've been saying reflection in the y-axis. It's not changed.
That's what I said.
X is greater than 1. You guys are saying horizontal flip or horizontal reflection. Stop it. Yeah. Sure, would you like to teach?
No way.
Not today. It's tiring. Okay. We're skipping this for now. Come here. All right. These are all base 3. These are all log base 3. Do you see that? We can only compare, so it's y equals log base 3. They want to know the transformations that happen to y equals log base 3. Do you see that?
Yeah.
The log bases have to be the same. Does it appear anywhere in your transformation? No, the log base 3 is a specific type of graph being drawn. We're just moving it. Same thing as exponential. I don't know what you're doing. I'm just waiting you out because I feel like you're going to hit them or something. So I don't know what you're doing. You guys are suspicious. Very sus, one might say. All right. I'm going to stand over here closer to you guys because that's what teachers do to get kids to not be sus. And yeah, I want the transformations and the mapping. Go. And then I want you to answer this. 1 BC. It should be an A. It's been a rough set of notes. Oh, so here we have y equals 2 log base 3 to x minus a half. I really hope you took that 2 out. That makes me very sad if you did that. You have to have a 1 in front of your x. This one, you're going to divide each term by 3, not the whole side, or that doesn't get you transformed form. So we get y equals 1/3 log base 3 of x plus 2. And then this one, we just have to subtract our 3 over. So we get 1/2 log base 3. We take a third out. -1 divided by a third is -3. Okay. Transformations. So we have a vertical stretch by a factor of two about the x-axis. We have a horizontal stretch by a factor of 1/2 about the we have a horizontal translation one half, right. All right, we can do mapping as well. XY becomes 1/2 x plus a half, comma 2y. Okay, the next one, we have nothing happening to the x's. So we would have xy becomes x comma 1/3 y plus 2. We have a vertical stretch by a factor of a third about the x-axis. And a vertical translation two units up. And the last one I'm just going to read. So we have a vertical stretch by a factor of a half about the x-axis. We have a horizontal stretch by a factor of 3 about the y-axis. We have a horizontal translation 3 units right and a vertical translation 3 units down. And our mapping would be xy becomes 3x plus 3, comma 1/2 y minus 2. All right. So we want the domain and the range of the previously transformed equations. This is supposed to be state the equations of the previously transformed equations above. Should we state the asymptote? All right. What's the range for all three of these? Y such that y is now in the reals. Or in interval notation, negative infinity, positive infinity. The whole way across, right? That doesn't change. Our domain, however, changes. Are the domain of all of these greater than? Yes, because there's no reflection in the y-axis, which would cause it to do this, right? So our asymptotes first, we'll do these. Our vertical asymptote. So this one's going to be x equals what? What's this one going to be? X equals? So normally x equals 0. What is it now? 1/2. Because our vertical asymptote is just our horizontal translation. This one's going to be x equals what? 0. Didn't horizontally translate. This one's going to be x equals 3. And then our domain is just greater than all of those because there's no reflection. So our domain in set notation would be x such that x is greater than a half, x in element of the reals, or 1/2 to infinity round bracket, which looks like a coordinate, but it's not. This one would be x such that x is greater than 0, x in element of the reals, or 0 to infinity. Then this one would be x such that x is greater than 3, x in element of the reals. Okay. Just so you know, when I record, I can hear everything you're saying because this is a conference microphone which picks up the whole room. In case you were just wondering. I've said that once or twice, but I think people have forgotten. I think. If you're farming, stop farming. Okay. I don't know what you're doing, but stop. So, diploma practice 7, 8, 9, 10. Go. The x-intercept, when you hear x-intercept, what should you think? Y equals 0. So I get 0 equals log base a of x minus d. All right. It says the x-intercept of the graph of the function f of x equals log a x minus d. What can we do? So we can go a to the 0 equals x minus d. What is a to the 0? 1. So I get 1 equals x minus d, and then x equals 1 plus d. We have the graph of y equals log x is transformed to the graph of y equals log, don't care, don't like you right now, I'm going to change you, to x plus 5 over 2. Horizontal stretch by about the y-axis by a factor of p. So p equals what? A half. In the horizontal translation, q units left. Q equals 5 over 2. And then they want them added. 1 over 2 plus 5 over 2 is 6 over 2, which is
3.
all right. Then the equation of the asymptote is x equals what? -2. The hardest part is you're going to have to remember that logs look like this. They curve up or they curve down, right? So they have vertical asymptotes. And exponentials have horizontal asymptotes. And horizontal asymptotes are y equals vertical translation. And logs are x equals horizontal translations. You need to understand why. If you're trying to memorize, it makes it a problem. If you understand why it has an asymptote here, the only thing that can move it is horizontal translation. You will do better to understand why rather than memorize. Okay, we have the graph of log 7. X is reflected in the x-axis. The equation of the image can be written as what base? What did you guys get? 1 over 7. Which I don't know what that is. 0.4.
How do you know that for sure, though? Like, how do you
test with two values?
I got it right, but like, how do you find that? Because that was guessing.
It was a challenger question, so you could put it in and look at your tables too. But what 1/7 does, if you take that base and you do flip it, it makes it have a reflection in the x.
Yeah.
Inverse it.
Yeah, it's the same as like if you have the 3 and then the third, and you made it be 3 to the -1, it was a reflection in the y-axis.
Well, how does that how do you write that equation down?
Log 1 over 7x.
You would do this thing.
You can't write out the and solve that.
Not really. You kind of understand that when you flip them, it does do that because it would be 7 to the -1, and the -1 could be brought out.
It's like, this laptop